Okay. Does this work? I haven't been here in a while now, have I? Hmm. This fixes something. All right. Change dashboard. No, it's not made for kids. Okay. Move this aside. Move that to the side. Minions been good. Do they deserve dead fish? My staff's been doing a decent job while I haven't been here. Yeah, I think they're more than deserving of some dead fish. Alright. Uh-oh. What do you mean file output is not correct? What are you talking about? My file path is not... Oh, yeah, because I changed back to this drive. Okay. No worries there. Change this. Get that stuff. And... Alright. We're live. Pretend to be excited for video time since I just hit start record. Hey everybody, how's it going? Today I'm gonna fix a MacBook. Here we have a MacBook that's not turning on and not charging. That my assistant did not open because they fucked up the bottom screw so bad that he could not get it out of the machine. So we're gonna see if I can get this bottom screw out, and no, it does not want to come out. So I'm gonna share a little trick with all of you. So what we do here, see this? These are fine-tipped snippers. This is an Exolite 175M. And what you can do with an Exolite 175M is you can grab the screw and get under the screw, which is what I'm going to try to do here because this screw is fucked. I'm just going to cover the customer's name so you can't see that. Nobody tries to call them, stalk them, do any weird shit. And we're going to get the overhead camera on over here, and we're going to see if I can get rid of this freaking screw because this thing is stuck. All right, so see this? So we take the Exolite 175M fine tip snipper. Drill in. Yes! And we turn. A lot of people try to do stuff with Dremel. I think that the amount of damage you're probably going to do when you're dremeling, trying to avoid damage to the case, you're going to wind up doing way more damage than you do with this. It's also cheaper and way better. Have you been sleeping well enough? I have been sleeping. I'm not feeling well for a number of things. Honestly, it's just not something I feel particularly excited to discuss on camera at this point in time. But no, a lot of people think that I don't sleep. I slept very well. I've been sleeping very well over the past few weeks. It's just something else altogether. So I am going to go over this, and we're going to try and figure out what's going on with this MacBook. So I'm going to turn on my power supply. I have And let me get my power supply software on. Let me get the multimeter software on the screen. All that good stuff so that you can see how much power this MacBook is actually using. So I'm going to turn this on. And come on, start. There we go. All right. And let's see. What do we have here? So I'm going to multimeter. Toggle on or off. Okay, it looks like we're taking 6 milliamps, which is pretty useless, as most of you might imagine. So this is an A1502. This has an A204924 board inside of it, and we're going to try and figure out why it is that this is not turning on. So I'm going to get my magnet, which was right over here. Just actually taped to the bottom of the computer. It doesn't make any sense that it was in a bag on the bottom. Strange, but we are going to get this board out of the case. We're going to see if we can figure out what's wrong with it. Honolulu's rail project price tag hits $12.4 billion. Don't talk to Erica about the rail. When you talk to Erica about the rail, it fucks her up inside. Like that's one of those things that just, I mean, if you want to convert a Hawaiian to a libertarian, just talk to them about the rail. So, yeah, every time I talk about the rail with Erica, her face kind of, I try to avoid talking about the rail with Erica because she's going to look like she's 50. And just, you know, in a month or two, if her face gets stuck with all those wrinkles and grimaces in it, like when I tell Eric about the rail, you could see she's like, and I know that that's not going to be good for your face because it's eventually going to get stuck like that. Did you get the straw in your case, pee-pee bus? Honestly, people here, they have zero desire or inclination to do videos, and that's quite obvious. Like, you know, people will do it, but there'll be some huff, some puff, some and it's just like, you ever hear Bill Burr with the girlfriend, where he's like, hey, can you listen, I'm really in pain. Would you be able to take the dog out? Oh, I mean, like, what, you mean, like, I can, but, like, I have a long day, and this happened, and that happened, and then Bill Burr says something along the lines of, fine, fuck it, I'll do it, and in his skit on why you don't hit a woman. So it's kind of like that, like, it'll be a yes, but it comes with a bit of guilt tripping. So it should arrive 10, top of the hour. All right, now, thank you very much. The people here really appreciate it, Mr. Kelly. Bill Burr is the best. I love Bill Burr. He's a fucking amazing comedian. It's really interesting because I like Joe Rogan's podcast. I genuinely enjoy listening to his podcast. I don't know what it is, but he's really good at getting out of people what other people, or he's good at getting something out of people that you just don't get when they go on other interviews or shows. But I was never a fan of Joe Rogan's comedy. Bill Burr, I think, is a genius legend comedian, but when I listen to his podcast, I don't find it particularly entertaining. But I really do enjoy Bill Burr's comedy. It's the 2012 skit, Arnold Schwarzenegger shit, all that stuff. It's fucking amazing. The grocery store. Apparently, I work at a grocery store. Wow. Jeez, must have forgot my apron. Like, oh, it's hysterical. I love Bill Burr. He's good. He's so, man. Yeah, you have a bad day, turn on some Bill Burr. It won't be a bad day for long. Okay, so we've taken everything out of the machine. So the first thing I'm going to want to do here is see if after I've taken everything out of the machine, if I still have the same thing where it's only taking 5 or 6 milliamps. And as you can see, it's still pretty much stuck taking 5 to 6 milliamps. So I'm going to open Flex Board View. Hope that the bugs have been fixed in spite of the fact that I never update Paul Daniels software because it would take away my reason to complain to him. And see if anything funny is going on here. So I'm going to, first thing I usually do in these videos is I check for a power rail that's responsible for getting a green light in the charger. I'm just kind of curious if any of you remember what that power rail is. So what power rail is it that gets us a green light in the charger? Can anybody remember? Ever tried DMT? Okay, let's try this again. Which power rail gets us a green light in the charger? You fucks. I ask which rail gets a green light in the charger, and you ask if I've done DMT. Jesus Christ. Okay, let's see. PP3V42_G3 hot. Very good. Yes, it's PP3V42_G3 hot. Yes, that is the rail that gets us a green light. So when we take a look at the schematic and the board view over here, I'm just going to turn this frustrating thing off so you don't see the number up there. You'll see that on this board, PP3V42 is going to power my SMC. And the SMC chip is what communicates with the charger. So this over here is my charge port. See if on the screen you got This is my charger. That's my charge port. And on my charge port, you're going to have adapter sense line over here. This is my adapter sense line. And this is where the charger here is going to speak to the system management controller here. And system management controller requires PP342 to work, as does this whole circuit over here that allows the charger to talk. So see, this over here is powered by PP342. This chip over here powers this chip over here, and this chip is what allows the charger to speak to it. So we're going to get in checking our PP3V42, and let's see if it's present, let's see if it's not, and if it's not, we got to figure out why. I don't see any obvious liquid damage on this board, but I haven't really looked at it under the microscope, but I'm usually able to spot this stuff without looking in the microscope, just from the amount of time I've been doing this. Now, let's see. I'm going to just take my multimeter here, and I'm going to measure and see what I get, and I get 0 volts on PP3V42, nothing coming into the machine. So the next thing we're going to do, anytime you're missing a power rail, what I like to do is I like to check the beginning and the end of that particular power rail, so I save myself some time. So when I go over to L7095 over here, which is where PP3V42_G3 hot is created, this area, this chip is going to take my 18 volts from the charger, or 12.56 volts from the battery over here, and it's going to turn it into 3.42 volts over here. What I want to do is I don't want to check, like, I'm not going to check here and here and here and here. It's a waste of time. What I want to do is I want to check the beginning and the end. And then we so there's a reason that I do this. There's a rhyme and reason to it. And let me just open the PDF in its own screen to make it a little bit easier, since we're not using the board view right now. So let's say that my problem is over here, right? Let's say my problem's all the way over here. And I check over here, and here, and here, and here. I'm going to miss the fact that it's over here. So the way I solve it is I check end, here. Then I check here, here. And I keep going like that. It makes life a little bit easier for me. So I'm going to check over here. Let's just get check back at the beginning. And to do that, I'm just going to exit the large screen PDF view and go back to the split screen view, because I need to see where everything is. So, I want to see what's coming in on R7020, but what is R7020? By the way, Paul Daniels is saying that we should probably try and have a dialogue back and forth with some of the manufacturers, because when I use the word board view and they're opposed to making board views available, they may not understand what I mean. When I say I am looking for a board view file and a schematic, I'm not asking for the thing that I just give to a manufacturer that allows me to completely replicate this immediately. That is a highly complex file with way more information than someone like me could ever need to do this job. What we're asking for is something that looks like this, where when it says R7020 on the schematic, I know where to go on the board. In the olden days, when you wanted to find R7020, you would look on the board, and next to every component, because there was space for it, it would actually say R7020. Everything is miniaturized now, and there's no space to put numbers on the board. So the only way to find where R7020 is in a file like this. And I think part of the right to repair movement is going to have to be clarifying things like this, because for all I know, the people that work there may not actually even know what it is we're asking for. It may really be a game of telephone where they say they're asking for board views, and then that goes to from the PR person or the government relations person to the engineering department person, and then they tell that person they want the board files. And then they say, board files? That would allow them to print out their own board on their own. We can't give them that. And then, it may just be something that's getting lost in translation. So just a little bit of food for thought. Hello from the UK, late night PP bus probing. Well, now it's PP342 probing. John DeComo says, I like what you just did. Throw some right to repair into the repairs itself. It draws people in, and you give some right to repair stuff to fix the overall problem. This is Paul Daniels' thing. So I appreciate that you just gave me credit for Paul Daniels' idea, and I'm not going to in any way protest you giving me credit for Paul Daniels' idea. Although I'll always take credit for Paul Daniels' ideas. Don't get it twisted. So we are going to go back here and check out where R7020 is. So R7020, it says, is right here. And we're going to flip our board over. We're going to have the overhead camera go back on. We're going to put the multimeter on, and I'm going to check and see what I get at R7020 on both pins, on pin 1 and pin 2. So on pin 1 is where we should be getting 18 volts from the charger, and I see nothing. On pin 2 is where it should be coming out. I also get nothing, which does beg the question of whether or not my charging setup is actually working. Well, that's a good one, because I haven't been used this desk for board repair in quite a while. So let's go back to the schematic and the board view. Now, I'm actually quite happy that I checked over here in the beginning after seeing that there was nothing in the end. Because again, what a lot of people do, this used to happen to a lot of my students, is they would say, well, there's nothing over here. How do we test the inductor? How do we test the chip? How do we test the diode? It's like, you don't want to test any of these things because you don't know if anything's getting to this. That may be a waste of time. So in sequence, remember, you have to do this, all the work that I'm doing, it needs to be done in a time frame where the customer is actually going to want to have it done. A lot of people say that component level repair is not economically viable, but I think the reason they say that is because they're missing these little strategies that kind of give you shortcuts to allow it to be. So I tried over here. There's nothing there. All right, now we're going to jump up again. F7005. Technically, I should have checked over here, and then over there, and then over here after. But, you know, who needs to listen to his own advice? I guess I was following it a little wrong. I should have zoomed out in the picture a little bit, admittedly. So we're going to check F7005 over here and see what I'm getting on the fuse. So let's see what the fuse has on it. And I'm guessing I'm probably going to have 18 volts there. Okay, 18 volts, so the fuse, all right, so let's continue. So now we know that our problem is going to be somewhere, let me just get this full schematic view on the screen. So our problem is somewhere between here and here. I'm going to guess that it has something to do with Q7010. Now, one thing to note over here is that a lot of the crap that you see over here doesn't actually exist. So like Q7020, Q7030, those, at least I have not actually seen that stuff on this board. So I just pretend that that stuff is, this over here, I don't believe that this actually exists. So this transistor over here, Q7010. Now, how does this work? That's a great question. You could check out some of my older videos on how these transistors work to get an idea. So this is a P-channel MOSFET. And if you weren't aware, you can just Google that chip and it will tell you that it's a P-channel MOSFET. You can also tell if it's a P-channel MOSFET based on the direction that all the arrows are facing, but I realize with new people, sometimes it's difficult for them to memorize all of that. The way a P-channel MOSFET works is that if you have a voltage on the gate that is lower than the voltage on the source, then the source will be able to go through the drain. So this is kind of like a light switch, but instead of you flipping it physically, you're going to flip it when you send the right amount of voltage or take away the right amount of voltage from the gate. So let's check out how this works. This is going to send voltage from the source to the drain when the voltage in the gate is lower than the source. Now the source is going to have 18 volts coming to it from the fuse up there, which means that I'm going to be expecting, if this is going to work, to have a lower voltage in the gate than the source. Now how does this work? Well, you have R7010 and R7011 over here that are going to be taking that 18 volts from from the source and putting it right on the gate, ensuring that the voltage on the gate and the source are identical, which ensures that this never opens. What does allow this to open is the fact that over here you have this diode that goes to ground, which is going to take some of the voltage that would have otherwise went to the gate and brings it to ground. This then turns this circuit into something like a voltage divider, where this on the bottom is, in some ways you can just kind of see it as a voltage divider, one resistor on the top, one resistor on the bottom, except here they're using a Zener diode, just to keep things simple. This is kind of like a voltage divider. So this is going to do, if this diode is working, is it's going to ensure that the voltage in the gate is lower than the voltage on the source by sending some of the voltage that you're sending to this gate over here via R7010 to ground. And I'm pretty sure, if I were to guess, that we are not getting a voltage drop on the gate, which means that this transistor is never going to allow power to go through it. I'm pretty sure that that means that D7010 is either flicked off the board or broken, and I'm pretty certain that, like most Apple computers, that this diode on this machine will have HA on it, because the diode is laughing at you for buying the wrong product, which I don't think it should. I think that's kind of mean. I try not to laugh at people that buy Apple products. You know, it's not for me to judge, but it's really kind of fucked up that the machine is actually laughing at the person for buying the Apple product. That's fucked up. So we're going to take a look at this diode on the board and see if my theory is correct. I'm going to turn on the microscope and the microscope camera so that you can all see what's going on the board itself as I probe around, and let's see. So we go over here, and as you can see, this diode over here is laughing. I'm just going to do a 90-degree rotation so that you can see that it's laughing, because right now the HA diode is upside down. So I'm going to take my microscope camera, and just to make it easy for you to see on the screen, yep, it's laughing at you. It's laughing at you. Again, it's screwed up. You shouldn't laugh at your customers. It's not right to laugh at the customer, but they laugh at the customer. So what are we going to do? First thing I got to do is I have to just tighten up the microscope stand so that it's a little less shitty. That's one thing that we got to do. And the next thing that we have to do is do some measuring. So on the schematic over here, now the gate, I can measure the gate on pin 2 of C7012. So we're going to go check C7012 because on each side of C7012, we're going to have the source on pin 1, source on pin 1, gate on pin of the transistor is on pin 2. So we'll see if the voltages are different or the same. And I'm pretty certain that this is going to be a problem of the diode failing. And then if that is the case, then I will replace it, and I will bet that this will be a happy little MacBook once more. So let's see if we can make this a happy little MacBook. Kopaz is laughing. It's not right to laugh. So C7012 is going to be right here next to the transistor, and I'm going to load that up on my microscope camera over here. We're going to zoom in on that a little bit. I apologize for the smudge in the microscope camera. This thing is about 7 years old. It's been through hell, a couple of moves, and it just doesn't. I could probably replace it with another one. I just want. So we're going to check each side over here. Now, pin 1 is going to be the one pin on the bottom. You can see that from checking the board view. That's pin 1, and then pin 2 is going to be the gate. So let's see. Now, pin 1 is obviously going to be 18 volts. We expect that. Really? What? Okay, that's weird. Whoa. Okay, this is actually just a blown DC in fuse. No way. No way! No way! No way it's that easy! Wow! Okay. It was actually just a blown DC in fuse. Okay. Now we're going to... Are you fucking kidding me? How the hell did I get a board this easy? Okay, it wasn't the diode. Okay, there's no short to ground. There's no short to ground after the fuse. Are you kidding me? Did I seriously just get a DC in fuse? There's no way in hell. No way. No way. Okay, I'm just checking for a short along the path here. The PP342. No short here. No short here. What? That's bullshit. Oh, if Paul sees this, he's gonna fucking ram me, come in here and fucking scream. No way. No way. I got a DC in fuse. You gotta be kidding me. Alright, let's see. PP342 has no short. I'm just checking some of the main power rails right now just to see if any of them have a short to try and figure out why a fuse blew. Alright, so PP bus G3 hot, 329 ohms. That's kind of weird. That's kind of weird. No way. What made the fuse blow? Again, the reason that I'm checking for shorts before I replace it is because I want to know what made the fuse blow. I'm not happy to simply replace the fuse without knowing why it blew. That being said, just my basic preliminary overview of it really does hammer home the fact that there's no reason for this fuse to have blown. Again, usually in this case, when this is the issue, it's that little HA diode that has died. That HA diode is a common piece to have broken, which is why I didn't really even bother checking the rest, because it's so common. It's not, I'm not used to dealing with just the fuse dying. It's just, we don't usually get boards that are that simple. But my God, it was that simple. All right. I'm just going to work this little fuse off of the board here. Yeah, maybe a bad power adapter. You know what? I'll check the current sensing resistors on the ISL6259 just to make sure that's all good after this part is done. Man, I can't tell Paul about this. I can't tell Paul I got a board with a bad DC in fuse. That's just... Just got my Atten. Great station. I feel like the master of hot air. I really like the Atten. I remember when I started doing this, and like a decent hot air station was like $500 or $600. And now the hot air stations that were $500 to $600 when I got them are actually shittier than the Atten. Technology has come a long way. Where is Sharky? Ooh, I have Sharky outside somewhere. I have Sharky outside. I actually scared the piss out of Chris the other day. He was using the Zalmau or something, and then he turned, and I just had Sharky behind him on my hand, and then when Chris turned around, he almost shit himself because Sharky was staring him right in the face. I know, it's probably not the nicest thing to do, but I couldn't help myself. He was the only one that fell for it. It's weird because he's like the smartest person here, but he was the only one who fell for the Sharky. Okay, the fuse has been replaced. And again, we're just going to do some preliminary looks at the ISL 6259 since this interfaces with the charger. Why the hell do you use so much flux? That's not a lot of flux. Why do you cheap out on the flux? The fuse, I've seen it blow by overclocking and bad adapter. That could be bad adapter. Check the good old current sensing circuit here. Yeah, this seems to be... Come on. Hold. Alright. So I have high expectations that this is going to work. Cam is here. Okay. So I've plugged it in the charger, and now it's taking 24 milliamps, no green light, not turning on. So we've got a bit of work to do. I really do part of me wishes it was that easy, but let's face it, life's never going to be that easy. So what we do here is, oh, okay, we're getting 18 volts there. Now we're going to check that our PP3V42 is present. PP3V42 is present. Now we're going to see if the SMC chip is turning on. Is the SMC turning on? It is, because I'm getting 12.58 volts, right? So I'm getting 12.58 volts on PP-Bus G3 Hot, which means that that is indeed turning on. Now we're just going to take a look at some of the one-wire circuit area. So remember, the SMC is turning on when it tells PP-Bus G, the chip that creates PP-Bus G3 Hot, to be 12.56 volts rather than 12.23, which is something I've covered in another video, how to tell when the SMC is working or not, that I'm not going to redo in this particular video. Now if we go over here and take a look at the adapter sense and all that, I'm just kind of curious to see if adapter sense is normal voltage or if it's 15 or 16 because the DC inboard died. Could be very possible that the DC inboard died and is sending 15 volts over to adapter sense. And that is not what's happening. Adapter sense is actually 3 volts, which is what it should be. It's just, so now we're going to check if, my charger's good. Aha. All right, so we just had to rub the charger a little bit there. And yeah, there we go. And just a little bit of zigzag over there. And the fan should be spinning shortly. Now, as you can see, it was taking 500 milliamps. Now it is not. Come on, you go, you. There we go. All right. Should probably just clean the charge port off a little bit. Let's see if we're getting CPU V-core here. Come on, give me 1.7 or 1.8 volts. There we go. So CPU V-core is present at the coil. And that's about that. It looks like this is a pretty straightforward fix. It was nothing but a fuse, which again, that just like, that never happens. That really, that just doesn't happen here. That's just crazy. I got a machine that was nothing but a fuse. Again, this usually doesn't happen, but it did happen here, and I'm quite happy that it happened here because I don't know. I'm never going to complain about getting an easy one. So that's about it for today. And as always, I hope you learned something. You probably didn't learn anything at all. I mean, even the biggest like jackass when it comes to electronics knows the first thing that you check is a fuse. Can you believe that I got a machine that was just a fuse? Because this never happens. It's crazy. Absolutely crazy. Anyway. See y'all later. And cut. All right. Oh, man. Paul gonna be pissed. Paul gonna be pissed. Go get your dead plants. Ooh, you're right there. Is that rust or just shitty Apple soldering? I can't tell. That's DC inboard. That's the shittiest solder joint I've ever seen. It literally looks like someone took a shit and they mistook feces with solder. Like that's... Why do you not work on PC laptops? Because people demand instant turnaround times on everything. And if I don't have parts in stock for that model machine, I can't give an instant turnaround time. And then people will be mad at me. So, and I already have enough people that are mad at me because I can't do things immediately all day long. I don't need more of it. It's like if someone shows up and goes, is this a screen or a cable? You're like, I don't know. What do you mean you don't know? I mean, I don't have a screen or a cable for this. Why don't you? Because there's like 10,000 different model PCs that come out every year. Maybe if I had a customer base that were more patient, reasonable, etc., then it would be different. But it's the Amazon priming of America and American businesses, where everybody's expected to do shit on a 1 or 2 day time frame, just kind of makes that difficult. I mean, a bunch of other places do it, you know. But I don't feel like it. Every time I've taken in a piece, most of the 1-star reviews that I got years ago, and some of them have been deleted, so many of these bad reviews were just like, I took it in and like after 3 days they had no answer. It's like, fuck face, it takes 5 days to order a fucking part. It's like, just, you know, fuck off. So I just send all the PCs to D&Q Computer. And, you know, again, D&Q is well rated, so they're doing something that I'm not. Let's see, are they still 5 stars on Yelp? Are they still 5 stars? Because I'm 4.5. Yeah, they're 5 stars. So, you know, they're doing something I'm not. I think part of what they're doing is they're charging everybody a $50 diagnosis fee just to look at it, which is, you know, part of what makes it make sense. But yeah. I lived in New York for 5 years. Patience is in short supply. That is true. Indeed it is. What's next? I charge a $75 fee that I only charge if they do not want me to fix it. Yeah, that works. If it works for you, it works. Okay, where was I for next? Berkelium gets hot. Fuck that. Board has 2 holes in it. Double fuck that. Actually, yeah, that makes sense. It has 2 holes in it. You technically could do that. But I wasn't even thinking of that when I made the pun. It's not just a quality mic, it's also the processing that gets done at the same time. So this is a royal pain in the ass to do, but I figured out how to run VST plugins with Open Broadcaster in real time, and it actually works. So what you hear is something different than what would otherwise come out of my microphone. Where was I? Also, you don't need an $800 microphone. Here, well, come on. You guys are being... Let's see. Let's see. Here you go. Someone has this thing for $250, and that's, by the way, that's more than what I paid for this one. Let's see. I have the browser on the screen. Yeah. Look. DPA 4065, and that's a lot. And it even says best offer. So you could give this dude a best offer, and you could probably offer him $150, and you know, he'll sell it to you. You know, you don't have to pay $800 for this microphone. Now, if you want to buy it new, then you're gonna get bent over at like $670 or something like that. Yeah, again, if you want to buy this mic new, then you know you pay $662 plus tax. It used to be $699 or $725, or you know, $879 or $950. Holy shit! Yeah, Sweetwater's fucking bending people over backwards for these microphones here. Yeah, the 4066 is the 4065. I think use the same capsule. $800. But again, you just go to eBay. eBay's your friend. My first one of these I got for $45. Zapro DK had a broken one, and he said, if you pay the shipping, I will send it to you. And that was, you don't got to pay too much. You're really paying for the capsule. I am Paul Daniels. I dual boot, so I have Linux for when I need. I have a streaming setup in Linux over here. So if I want to do, the lower level, drive cloning with DD Rescue, I can for drives that are fine with that. And I also have my Windows set up because I don't hate my life that much to continue torturing myself with Linux. It's not just expensive because they're built to be used in production. It's just that most of the head-worn mics that you'll try suck. Most of them are genuinely horrible. All right, we're going to find something else. Mal. Pro 27. That is no fun. Clicking hard drive, screw that. That's Steve can have fun with that one. 820-3330 taking 0.6 amps and not turning on. You're a missing platform reset L, aren't you? So does anybody want to watch me waste 30 minutes on a board that's missing platform reset L that has no hope? Countryman mics aren't awful, it's just they cost the same as a DPA for a lower quality. 0.6. All right. Slot I2. Be right back, folks. Be right back right after this commercial break from our sponsors. I2.
No,
I ate too much, but you all enjoy it. Thank you.
What did you eat?
I don't remember, but I ate something.
Okay.
Oh, hold on. Can you?
Yeah.
There's a special box of vegetarian stuff only.
That looks good.
If you want.
I love this. I love snuffing the wasabi. The wasabi stuff is amazing. It goes up your nose whether you want it or not.
Yeah, just give it back to me.
Oh yeah. Oh fuck. Oh fuck. Oh cool. Oh cool. Thank you. Crisis averted. Enjoy. Hello.
How are you?
Okay. I got recognized. Yeah. I need a bigger mask. Okay. This mask is not good enough. People can tell it's me. Okay. Hey everybody, how's it going? So today we're going to get started with a 2012 MacBook Pro, an 820-3330 board that's taking 600 milliamps and not working. This is typically platform reset L missing and is usually a gigantic waste of time. And the viewers of my stream decided that they want to watch me waste a gigantic amount of time because, I don't know, they just kind of enjoy screwing with me. So we are going to do that right now. We are going to see what's going on with this machine, see if we can figure out what's wrong with it. What's wrong with it is missing platform reset L probably. And we'll see if we can fix it. So when I plug the charger in, let's take a look here. It's taking 600 milliamps and the fans are not spinning. So I'm going to take the board out of the case. We're going to try and figure out what's going on, what's wrong with it, see if we can fix it, see if we can make it work again, see if we can make this a happy MacBook. This is a board that doesn't often fail. This is the one that was made right after the 2011 with the constant GPU fails. It's a 2012 MacBook Pro, but it also doesn't have that U8900 problem that the Retina does, even though it uses the exact same chip to power the GPU. Whoever engineered this machine had a clue what they were doing. So I'm going to grab my magnet. We are going to take the screws out of this machine, and we're going to get started. That is a really old Kingston SSD. Yes, this is a very, very old computer that we have here. This is from 9 years ago. This is old. This is old. But it's, you know, someone put some money into it, some care. Looks like they replaced their CD drive at some point, and looks like they didn't screw down their CD drive after replacing it at some point, but you know, or this. They actually didn't screw in their speaker. That's triggering me. That's triggering me. Yeah. Loose screws. Loose screws drive me nuts. Okay. So, loose screws are no longer loose, except for the ones in my head. Maybe it's time to start replacing PCHs, says Paul Daniels. If you want to put that much into this old thing. I bet Chris would have fun doing PCH replacement and doing a clean ME region on the BIOS. But then you also have to find a PCH that's good, and this is 9 years old. So we're almost coming up on 5 years since I did my first live stream on YouTube. I believe my first live stream was, I think, around summer or fall of 2016. It's kind of crazy when I think about it. The amount of life mistakes that I have made from then to now is just crazy. Like, I'm just thinking about all the things that I did that were really just stupid, pig-headed, asinine. It's crazy how much I've managed to compress into such a short time period. You ever do that? You just like notice that it's been a milestone since something you did something, and you just think of all the things that you've done wrong in that period of time. Okay, this is filled with dust everywhere. Alright, so there's a few things that we're going to do. First thing I'm going to do is I'm going to go through all of my SO rails, because I imagine 600 milliamps is either going to be a PP bus short or a missing SO rail. So on these machines you have your G3 hot rails at the bottom, you have your S5s, your S4. S5 is when the computer's off, S4 is when it is in hibernation, S3 is when it's sleeping, and SO is when it's on. And there's going to be power rails for each one, and you need the bottom ones before you get the top ones. So I'm going to guess that there's something going on where either PP bus G3 hot is shorted to ground behind door number 1, or behind door number 2 an SO rail is missing. This machine is an older one, so it's going to take about an amp to an amp and a half when it's on. Now PP bus G3 hot is there. So let's get to the board view. Isn't it about time to hire and fire Kopaz again? As I said, I've made enough bad decisions and I'm not looking to make more. Okay, so platform reset L. Is this missing? This probably is missing, isn't it? Why am I going to waste time on something like this? Why did I agree to this? Why did I get you guys to get me to agree to this? It's not nice. Okay. So we go down here. And platform reset L is missing. Now, could something be bringing it down? Maybe. Platform reset L goes to numerous different places. So platform reset L over here goes to this. There's a resistor for XDP PCH platform reset. PCA reset. SMCL reset. You could technically, if you really wanted to drive yourself nuts, remove the connection over here for all of them. Like if you really wanted to. But it's going to be the PCH, so like doing that is a gigantic waste of time. Again, you could do it. It's just who the hell wants to do that when you know that it's the PCH? Still thinking about it, but like I shouldn't be. Because that's dumb. I shouldn't be thinking about doing something that's dumb. How does one test the PCH? By checking if platform reset L is missing. Then you can kind of stare at the board for a while. You know, if you stare at it for a while, you can kind of intimidate it into working again. It's a fairly dirty machine. Kind of curious what if platform reset L would just come back after a cleaning. I have my doubts. Many doubts. It could always be tried. This is a really dirty board. There are chips where I can't even see the pins. This is an A1286 MacBook. It's really dirty. There's dust everywhere. And if you really wanted to drive yourself crazy, you could replace the PCH with one from AliExpress or eBay. But you know how that's going to go. I'll leave this for reassembly to try a different... Perhaps try ultrasonicing and see if that changes anything. But otherwise, that would be pretty boring. Pretty uneventful. Chris will have fun with this one. Okay, what do we get next? All right, so that's about it for today. I'll see you next time. Thanks for watching.